Okay, so this is for Mrs. Cucci's College Now Pre-Calculus class. This is the second part of lesson 2.5 where we left off. We should be on page 3.6. And we're talking about vertical stretching and shrinking. So, if we have the graph of y equals a times f of x, it can be obtained from the graph y equals f of x by stretching vertically for when a is greater than 1, or stretching vertically for when a is between, or the absolute value of a is between a and 1. I'm sorry, yeah, shrinking vertically, not stretching, I apologize. Okay, so when a is less than 0, the graph is also reflected across the x-axis. The y-coordinates of the graph of y equals a times f of x can be obtained by multiplying the y-coordinate, y equals f of x, by a. So essentially what we're going to be doing is we're going to now start multiplying by a specific factor of a, and that's going to stretch or shrink depending on what that value of a is. So if I look at my first graphs here, my starter function is this blue function, x cubed minus x. And what I've done is I've taken it and I've said, okay, I'm going to take my values of x and I'm going to multiply them by a factor of 1/2. Okay? So if you've noticed, this graph has changed for us. So what we need to determine is how it's changed. So, since my c value, or the value I'm multiplying x by, is less than 0, okay? I'm sorry, less than, it's between 0 and 1. It's not greater than 1, it's between 0 and 1. The graph is stretched horizontally. It looks like we've taken it and we've pulled the sides apart. We're stretching it horizontally, okay? So that's if the value of c, which in this case is the 1/2 that we're talking about, right? If that value is between 0 and 1, we're going to be stretching horizontally. Now in this case, let me move these apart so it's easier to see. I've got my original function, x cubed minus x. And now I've got my other function, and my c value this time is a negative 1/2. So again, it's between 0 and 1, so we are stretching horizontally, but by tacking in that negative 1, we've done something else, okay? We've taken it and we've flipped it across the y-axis as well. So not only has this been stretched horizontally, but it's also been reflected over the y-axis. All right, so horizontal stretching and shrinking, the graph of y equals f of c of x can be attained from the graph, thought I had gotten these, of y equals f of x by shrinking horizontally for when c is, the absolute value of c is greater than 1, or stretching horizontally for when c is between 0 and 1. For when c is less than 0, the graph is also reflected over the y-axis, and the coordinates of the graph y equals f of c of x can be obtained by dividing the x-coordinates of the graph by c. So let's take a peek at another function here. Okay, so I've got my graph, right? And this is my graph of f of x. So what we're going to do is we're going to perform some operations on this graph here. Okay, so the first one I'm going to look at is I'm going to take on a piece of graph paper, I'm going to graph my original, I'm going to look at my original function, which is on this page here, and I'm going to graph g of x, which is 2 times f of x. Now if we think logically, we know that f of x means y. Okay, look at y equals f of x. So all I'm doing to my new function is I'm multiplying that y value by 2. Okay, so I'm going to open up a page here. Put this over. Okay, so let's start thinking about this. I know I've got some specific values, right? I know I have, and I know you can look on your calculator as you're doing this, but I have these points. I have negative 5, 0. I have negative 2, 2, 0, 0, 2, negative 4, and 4, 0. So if I'm looking for the function g of x equals 2 times f of x, I'm looking to adjust these points accordingly. And again, f of x is just y. Here are my y values. So my new points become negative 5, 0, negative 2, 2 times 2 is 4, 0, 0, negative 4 and 2 becomes 2, negative 8, and 4, 0 becomes 4, 0. So those become my new points, and I plot accordingly. 1, 2, 3, 4, 5 zeros, right? Negative 5 zeros right here. Negative 2, 4, 0, 0, 2, negative 8, okay, and 4, 0. So I've got my points. And based off the graph, this is going to be straight, straight, and then parabolic. So there's my new version of my graph, okay? Now, my old graph was 5, 0, negative 2, 2, 0, 0, 2, negative 4, and 4, 0. Looked like this. Okay, so what I've done is I have stretched this vertically by a factor of 2. Okay, it's been vertically stretched by a factor of 2. Okay. The next one is it wants it 1/2 f of x. And again, if I'm multiplying the entire function, it's a vertical stretch or shrink, okay? 1/2 times f of x this time. So we can put that right on top as well. So this time we're multiplying by 1/2. So again, still the y values. My new points are negative 5, 0, negative 2, 2 times 1/2 is 1, 0, 0, negative 4 times 1/2 is negative 2, and 4, 0. So negative 5, 0, negative 2, 1, 0, 0, 2, negative 2, and 4, 0. So again, there it is. So my original is my green function, okay? When I multiply by 1/2 f of x, it's a vertical shrink. When I multiply by 2, right, by 2 times f of x, it was a vertical stretch. So hopefully you guys see the difference there. If the value of a is between 0 and 1, it's going to be your shrink, okay? And those should be less than signs, not less than or equal to. Sorry about that. Okay. If it's greater than, it's going to be a stretch. Okay. So the next one, f of 2x. And now this one's a little bit different, right? We're not multiplying the entire function. We're multiplying the value of x itself. Okay. So let's take a peek at what that's going to look like. And of course, we're going to start with my original. Negative 5, 0, negative 2, 2, 0, 0, 2, negative 4, and 4, 0. Looks like this. Okay. And what I want to do to it is f of 2x. Hope that's what I was doing. Let me go back to peek. Yep, f of 2x. So what we're doing here is we're taking it and we are multiplying that x value by 2. Okay, we're taking and multiplying that x value by 2. I apologize. Let me go back here. This value here, this value is greater than 1, right? We know the absolute value of 2 is greater than 1. So if I go back and look at my rules, it says that if it's greater than 1, what we do is we have to divide the x-coordinate by that value of c. Okay? So my value of c here is 2, so we're actually taking and dividing my x-coordinate by 2. So this becomes negative 5 halves, or 2.5. Negative 1, 2, 0, 0, 1, negative 4, and 2, 0. So I divided all of these by 2. Sorry about that. Okay, so we plot our new points. We get negative 2.50, negative 1, 2, 0, 0, 1, negative 4, and 2, 0. Okay, so what this is it's a horizontal shrink. When the c value is bigger than 1, it's a horizontal shrink. Okay, so our next one is multiplying by 1/2. Okay, so the next one's multiplying by 1/2. So this is going to be a stretch, and this time we're going to multiply by 2. Okay, multiply my x value by 2. So negative 10, 0, negative 4, 2, 0, 0, 4, negative 4, and 8, 0. So negative 10, 0, negative 4, 2, 0, 0, 4, negative 4, and 8, 0. Okay. So this one here is my f of 1/2 x. Okay, so we multiplied that one by 2. In the green, we divided by 2, showing a horizontal stretch and a horizontal shrink. We've got one more to do, and that is our f to the negative 1/2 x. Okay, so again, we're not only multiplying by 2, we're multiplying by negative 2. So all these values are just going to switch on us. 10, 0, 4, 2, 0, 0, negative 4, negative 4, and negative 8, 0. So 10, 0, 4, 2, 0, 0, negative 4, negative 4, and negative 8, 0. Okay. So now this one, what's happened is we have stretched it and reflected over the x-axis. So it's stretched and reflected over the x-axis. Okay. Okay. So we are going to actually take a look at this one in class. We're going to do it when we come into class right at the beginning. Okay. So please make sure, I want you to attempt this at home on graph paper. I'm not going to go over it right now. I want you to try it at home, and then we're going to come in and go over it as a class tomorrow. Okay, guys, thanks.